Yes.
Any questions on that?
Yes. So, how about 19?
Oh,
25?
whoa. 19.
Yeah.
25.
And this is from 3.10. That's kind of it. The only thing I noticed with 19 is, sorry, if a 5-foot-tall woman walks at 8 feet per second toward a street light that is 20 feet above the ground, what is the rate of change of the length of her shadow when she is 15 feet from the street light? So if she's 15 feet from the street light, she's 5 feet tall, wouldn't she be right underneath the street light? Yeah, and the book doesn't do it that way. The book does something else.
What number is that?
19.
19.
So 410, 19.
Yeah,
310.
310.
We can do 410 number 19.
I hope I can. You guys, is that decent?
Yeah, I have another question.
Yes.
In the related rates, we use a lot of the formulas, basic geometric formulas
Yes.
a lot.
Yes.
How many different geometric formulas are there? There's spheres, cones, rectangles, triangles.
Yeah, just know all of them. Nice
Okay.
job. That's-
Can you maybe like post
Yeah.
the equations
No,
online
there's
or
a finite
something?
number of them. It's finite.
No, technically it's not. Like if you got a pyramid, you can have an infinite number of different types of bases, and an infinite number of shapes. Like you could have like a triangular based pyramid or a square based pyramid or a yeah.
Nah, it's
whatever.
just 1/3 times the product of the corresponding
Oh.
rectangular solid. It always works. It always works.
So do we have to know that one?
Well, we already do from high school geometry.
That was over 10 years ago.
I'm glad you used the word.
That was
only. That
7th
makes it all
grade.
better. So number 19, a 5-foot-tall woman, so she's 5 feet tall,
Yeah.
walks at a certain rate towards a street light that is 20 feet above the ground. So 20 feet. There's a light source. What's the rate of the length of her shadow when she is 15 feet from the street light? And at what rate is the tip of her shadow moving? So she's 5 feet tall. She's walking at a rate of 8 feet per second towards the street light. That means I need to quantify this time. Oh, you know what, you guys? I lost it. Help me with this. In terms of mathematical symbols, what the heck does this mean?
dx/dt.
Thank you. So dx dt is equal to,
8.
8 feet per second.
I can't hear you.
8 feet
8 feet per second.
I can't hear you.
Negative
Thank you.
8.
Negative 8 feet per second. Did you guys see that?
No.
Well, because think about it. If she's walking towards the street,
I see.
so it's going to be a negative rate of change. And I want to know what the rate of change of the length of her shadow is changing. Well, actually, watch. Light shadow.
On
I
that one,
shouldn't say light shadow.
we should have put
Light
0.5 in
rays
there.
hitting the tip of her head,
-0.5.
hitting the ground.
That's what the book
I
is
think
right.
this length right here is the length of her shadow. And I think the question right here above my squiggly line is really asking this. We need to find dl dt. And I think, mathematically speaking, it's far too difficult to build an equation involving dl dt, but I think it's a heck of a lot easier building an equation relating L to maybe x, and maybe differentiating with respect to time.
I have a question. So when they say that she's 15 feet from the street light, does that mean that she is 15 feet from the base of the street light, or does
Yes.
that mean her head is okay?
You know, I guess in the context of the English, it's understood that it's really that her feet are 15 feet away from the foot of the actual street lamp. That's what's implied. I know it's not very clear, but that's what's implied.
Oh no, because it explicitly states that the street light is 20 feet above the ground, so aren't they trying to find the distance from her, like, diagonally up to it? Because it says that it's 20 feet above the ground.
Well, think about it. This is her. This is a street lamp. I think the distance between one object to another in Euclidean space is going to be a perpendicular distance. So I think it's kind of understood that is this perpendicular distance between the woman and the street lamp,
Oh, okay.
which I think is the same as length of x.
Yeah.
I think this is implied.
Okay.
So, you guys, I'm in trouble. Shoot. It's too difficult. I'm not going to deal with it. I'm not going to build an equation relating dl dx dt to dx dt. Instead, I would rather build an equation relating x to L and then differentiating with respect to t implicitly. So what does the Pythagorean theorem say to you? I think it says something complicated. Because if I were to use the Pythagorean theorem, I'd have to talk about the length of the hypotenuse, I don't know, this small triangle or maybe the big one, but that's not L or x. I think it's way too complex. Somebody tell me an easier way to relate x to L, geometrically speaking, looking at this picture.
Make them both relate to theta.
What theta?
If you draw a second triangle stemming off from the top of 5 feet across to the lamp,
Oh, really?
you have
Okay.
two triangles that will always have the same theta.
Or you can just work off the theta down there.
You mean these two angles the same?
Yeah.
How do you know that?
It's a light rating. It's
Because what?
straight.
What's straight?
The light ratings.
Just like high school geometry.
But what about high school geometry?
Interior angles.
Not alternate interior angle, but
Similar
Coordinated interior angle.
corresponding. Corresponding angles relative to a transversal for two parallel lines are understood to be congruent. Do you guys remember that theorem from high school? No, you're not supposed to. It was an assumption. It was a postulate. It was an axiom. And then from there, you proved other things about interior angles, congruent, things like that. Okay, never mind. Let's not go there. I got a better idea. What's the relationship? Watch my fingertips. What's the relationship between this triangle, vertex to vertex to vertex back? In this triangle, vertex to vertex to vertex and back.
Similar.
How do you know that?
Because the angles are the same.
Stop using that phrase.
The
Randy?
angles are the same.
What angles?
All of the interior angles.
You know you're right, but all you need is two pairs of angles. I think both the small one and the large one share this common interior angle. But they both also have a right angle here and here. And whenever you've got two pairs of angles congruent, two triangles, you can proclaim that they're similar. Who cares?
We do.
Yeah, we do, because it means the sides are
Similar.
well, the triangle is similar, but the sides are proportional. Which means the horizontal length of the small right triangle. It's all English, exactly. I think the ratio of the
And
length
math B.
well, math B is a goy.
Oh, jeez. Of course it is.
I think the ratio of the horizontal length of the small right triangle to the length of the horizontal length of the large
Plus L.
has got to be the same as the ratio of the vertical leg of the small to the vertical leg of the large.
20.
And if I were to remove fractions, wouldn't that mean the 4L is equal to x plus L?
Sure.
Or doesn't that mean 3L is equal to x? Ah, shoot, I haven't come close to answering the question. I guess I'm trying to find dl dt. I don't see a dl dt. How do I create it out of thin air? I would. Because I think as this woman's walking closer and closer to the lamppost, both L and X are changing with respect to time. So treating L and X as functions in time implicitly, let's differentiate implicitly with respect to time t. And if I were to differentiate, wouldn't I get this? Actually, I'll be quiet. What do I get? Equals.
dx dt.
Okay, I just differentiated, guys. It's time to take a break, take a snapshot in time, analyze what the heck is going on at this particular point in time. And at this particular point in time, oops, did I leave my book? Sorry, guys. At this particular point in time, I don't remember.
Yeah, plug -8 in for DXTT.
Thank you. The woman's walking at a rate of 8 feet per second towards the street line, so I think DXDT is,
-8 feet per second.
and it's also the case that 15 goes into,
Wait, what?
you got a problem?
How do we do that?
I don't know, tell me.
Shouldn't DLDT be
What do you want?
-8/3?
Good, I think DLDT is just DLDT. I don't know what it is. That's the
That's what we're
question.
trying to find.
Where do I plug in the 15?
Nowhere.
No.
What?
Why?
Good point. Why? I mean, in my equation, relating DXDT to DLT, there is no place for the value of, I forget it, sorry.
15.
Well, that's the value for X, excuse me. So there's no good place to put in the value for X. That means a 15 is a,
Throw off.
what's that?
Irrelevant number.
Throw off.
What do you call that? The first environmentalist, what do you call that?
Unique.
Red herring? The early environmentalists in England.
What?
Detracting the hot box hound who spread red herring on trees to detract it. Anyway, it's a distraction. Let's come back. Yes or no, can I solve for DLDT?
Yes.
Oh, thank you. So DLDT is equal to -8/3. Actually, I forgot my units, so they feet per.
Feet per second.
Thank you. You know what, you guys? I just ran amok with my mathematics, my algebra, my calculus. I forgot what type this represents. What does this represent in English?
How fast
How fast
the rate is, the shadow is
the shadow is
decreasing
decreasing in length.
as she approaches the lamppost at 8 feet per second,
Thank you. Under these conditions, I agree.
under these conditions.
And so, does everybody agree? I've answered the question.
Yes.
No.
No.
I've answered the previous question. I found the rate at which the length of a shadow is changing.
Oh.
I never answered the truthfully underlying question. At what rate is the tip of a shadow moving?
Oh god.
Isn't it the same?
What's that?
No,
No.
because as she's moving closer, the shadow's getting longer, so it's just.
-8/3 plus. Plus.
The shadow isn't longer, it's getting
-8/3 plus.
as she's moving closer.
Nothing.
Oh, yeah.
No, something.
Oh.
You're trying to second guess me.
That doesn't always work.
Didn't
4L?
How quickly.
What justifies you to say that?
Change of the length of the
Because
shadow.
the tip of shadow is,
Increasing. No, decreasing.
yes, decreasing, but
So.
she is also moving towards the street light, so.
So you have to add
This sounds like
DLD.
Harry Potter mathematics.
Yeah, actually, I
You are 100% correct.
know.
You are 100% correct.
Don't you add DXDT and DLDT together?
Why?
Because she's moving, and then her shadow is shrinking, so you're trying to the tip of her head of the shadow is moving at a rate that is equal to how quickly she's moving and how quickly the shadow is shrinking.
I agree completely. If I'm going to try to find how fast the shadow is, I can't speak, sorry. If I'm going to find out how fast the tip of the shadow is moving, I think what it amounts to is this. If the distance from the pole to the tip of the shadow is d, I think I'm trying to find ddt. But I think d is equal to nothing more than L plus x. So I think to differentiate d with respect to time t, I just need to differentiate L with respect to time t and add to that the derivative of x with respect to t time, which represents time. And I think I just found DLDT to be, I don't know, is it -8/3?
But isn't that only DLDT? Isn't that DLDT at 15 feet?
You know, you're right, but at this one point in time, I still think I can think of the distance of some of these two beasts. And at that one point in time, I still think the rate of change of d with respect to t is some of the rate of change of these two beasts with respect to t.
So
Just because I'm looking at a specific time doesn't mean this doesn't hold true.
Oh, they're implying that it's at that specific time.
Absolutely. They're saying when she's 15 feet from the street line, what the heck's going on?
Oh, okay.
And by the way, I think DFDT was given as -8 feet per second. So I think in the end I'm getting negative, I don't know, is that 32? Help me guys, feet per second? Please double check my arithmetic.
That line on top of the O, is that saying that it continues implying the so? Or-
Yeah, that's exactly what it means. It's a repeated O.
Oh, okay, that makes sense.
Isn't that
It should be negative 32 over 3.
My apologies. I did get a negative 32. I just forgot to put it on there. I agree. In other words, negative 8/3 plus a negative 8 really is negative 32.
What if they weren't implying or whatever that it's at that specific point in
I'm
time?
in deep trouble unless the rates of change are constant.
But
If the
they're
rates
not.
of change are constant, actually, in this particular case, actually they are. They're constant because when you look at the relationship between dLdt and dxdt, there's no L's or X's in there.
Oh, I see.
One's a constant multiple of the other. So I kind of got lucky to feel in this example that they were constant rates of change. If they didn't tell me, oh, take a snapshot when she's 15 feet from the street light, I still wouldn't answer the question. Actually, if she's 27 feet from the street light, how's this answer going to change?
I see.
It's not. There's nowhere to plug 27 in for X. I think it's going to remain the same. It's independent of what the heck X is. Guess
Wait,
happy?
is that like realistic though?
100%. In my picture, I'm not pulling any strings. I think the geometry I used to build the corresponding equation is absolutely accurate because these really are similar triangles. Nabil, assuming that the street light really is vertically out, and she's not leaning to one side.
Okay.
Assuming she's standing straight up.
So as long as light doesn't happen, we're good.
And-
As long as light's not happening, it's good. Right. You know what? If she were leaning, who cares? What are we going to use instead? We're going to use the extension of the Pythagorean theorem. You see. Thank you. Kind of groaning. You're groaning. Oh, am I leading on this? Jeepers. What's the next question? Number
25.
25?
What shadow thing?
Oh, we already did it. He just did it the way the book did it. They just didn't really word it. as
Did I
well
do
as
it the way
they
the book
should've.
did it?
Oh, yeah, yeah.
I did?
Yeah.
I'm sorry.
I was just freaking out about it because, it really made it sound like she was directly under the street light.
Well, I really would rather
Yeah.
guess the question differently.
Yeah.
But, when I come to class, I'm just doing what's natural.
Yeah.
It's a little
I don't-
upside down.
I don't
Just a little bit.
So, yeah, it's a little.
No, it was intended, it was intended. Okay, hold on a second. I'm so bad with these names, I'm sorry. You guys, is that clear in terms of focus?
Yeah.
So I had a question.
Sure.
It says, hint, the area of a sector of a circle radius r subtended by an angle of theta is r squared theta over 2. Are we going to get the same hint on the test as well? Because I don't know that. I don't think I'm ever going to know that.
I don't know how I would have figured that out.
Yeah,
That's what was
it's just
really freaking me out about this.
I would-
What?
I just assumed you knew that.
no.
Yeah, it's just a circle divided by the angle.
Just the what?
If a full circle is pi r squared,
Yeah.
then if you're looking at half a circle, well, it's just
Pi over 2
yeah.
r's.
But where
R
would
squared times theta over
A
2?
circle's radius
Okay.
r.
Yes.
Let's suppose it's the center. Here's another radius arm.
Okay.
Suppose I got a central angle theta.
Okay.
Let's take a peek at this area right here. I'll call it dumb. How about A? That's the area that circles the sector.
Okay.
Wouldn't you guys not agree that just this intuitive notion of similarity, the ratio of the area of the circular sector to the area of the entire circle should be nothing more than a ratio of the measure of central angle subtending that region for which I've got a circular sector to the angle for which I'm subtending one full revolution, giving me the area of the entire circle, which is
2 pi.
Now, in solving for A, I'd probably take both sides of the equation and multiply both sides by the denominator of the fraction on the left-hand side. Ah, shoot. Tad bit of cancellation. Doesn't it tell me that the area is nothing more than 1/2 r squared theta? You're supposed to jump. And say, "Oh, joy." But you get to write that out of thin air, can't you?
Of course, yeah, it's no
Okay,
problem
good.
at all.
I'm glad. Okay.
What? Goodness, why wouldn't I?
It's just a common derivation you have back in trigonometry. Yeah, I feel so alone.
I think we took the wrong trick.
I think I took the wrong every math class.
What if the area you're trying to find isn't a slice of the pie, it's, a line across the bottom of the.
Oh, that's so cool. You mean like this?
Whoa.
Yeah, that one we got.
That is so cool, because I think that area is going to be nothing more than the area of the circular sector, minus the area of the triangle. But that would be nothing more than the area of the circular sector, which is 1/2 r squared theta, minus the area of the triangle, which could be interpreted as 1/2 times the product of two sides times the sine of the included angle of two sides. I'm serious. Isn't that second alternative idea of measuring the area of the triangle? I just took the area of the whole circular sector and took away the area of the triangle. What's that?
You gave us this problem in trig all the time, but you never showed us this formula.
Oh, when you took trig, we used this repeatedly in quizzes. Oh yeah.
Yeah, but we never saw this formula.
Oh, I know, but you just put things together. Sorry, but I'm serious. I'm serious. I never read the question. I'm sorry. Can I come back? Draining a half-cylinder tank. Oh, down here. So a trough is a shape like a half-like? Oh, I think it meant is a half-cylinder with length 5 meters and radius, 1 meter. And the tank is full of water when the valve is open and the water flows out at the bottom of the tank at a rate of 1.5 cubic meters per hour. Oh, forget the hint. How fast is water level changing when the water level is 0.5 meters from the bottom of the trough? I don't know. Any ideas?
Well, first we know that if the volume of water is V, then dV dt is 1.5 meters cubed per hour. And then you can just find out what the volume is at, 0.5 meters from the bottom of the trough, or how do you pronounce that word?
Trough.
Trough. And then from there, just plug in V, and then,
But when you say plug in V, I'm going to need an equation relating V to the quantities. I mean, if you take a look at the cross-sectional slice of the front of this face, here's a trough.
oh yeah, just come up with
Here's the water level. And if I want to know how fast the water level is changing when the water level is some meters from the bottom of the trough, actually, if I know something about how the volume is changing, I need to compute the volume of this body of water.
So you need that formula.
I need something.
Do pi r squared times whatever the length is divided by 2.
In that area.
Where'd you get pi r squared?
Well, because that's the circle, right?
Over 2 though.
And then you got to multiply it by the length of the whole thing,
pi r squared divided by
and then you
2.
got to divide it by 2.
Yeah, I'm missing it. Tell me what to write then. So the volume of the body of water is?
Pi r squared.
Over 2 times the.
Wait, where are you getting pi r squared over 2?
Isn't pi r squared the area of a circle? And so if you multiplied that by 5 meters, then you're going to get the area of a cylinder, and then, or the volume of a cylinder, right?
No, because that's only the area for when it's completely full.
Yeah, exactly.
Yeah, that's what makes me nervous.
Oh, okay.
Is it going to be related or corresponding, even though like the shape's going to be different? So wouldn't it be like a whole nother? Wouldn't it be a different
It's gonna be that formula.
formula?
Yeah, I didn't see that one over there.
Exactly.
But
That's
the-
what you're looking for, is that outer sector.
I think so.
The
Watch my
formula, the whole trough would be of a half circle, right?
You know, the
Half
front half
cylinder.
is. If it's full, yes, but I think the water level is not completely full.
Yeah.
And so, you guys, check this out. Different color pens. Forget about the depth. Let's not talk about volume. Let's talk about area of the front face with the water level. Do you guys agree, if this is a central angle theta, that I'm really looking at the area here in blue to constitute the area of the water level in the front face?
What?
Partially.
Partially, what am I doing wrong?
You don't want the whole area.
I don't want the whole area that's sector, I wanna,
You just want the little subsector above
so I wanna subtract,
the area of the triangle.
The area of this triangle. I think you subtract the area of this red beast. And I think the difference in the area of the blue beast and the area of the red beast is gonna give the area of the front face of the water, the body of water. I know it's area, not volume, but I'll just multiply the darn beast by whatever the dimension is back there. I don't know what it is, 5 meters?
5 meters.
Did you guys see our point?
Yeah.
So I think the area of the front face is nothing more than the area of the circular sector minus the area of the triangle. So the area of that front face is going to be nothing more than 1/2 r squared theta minus the area of the triangle, which is 1/2 the product of those two sides times the sine of the included angle. Which means the volume of the body of water for which I've got this particular region as an area in the face is going to be nothing more than 1/2 r squared theta minus 1/2 r squared sine of theta, all of which is being multiplied by, I have no idea. Was it 5 meters? Which I think means the volume is going to be nothing more than, 5/2 r squared theta minus 5/2 r squared sine of theta. Now you guys help me with this, help me with this. As the water level is rising or decreasing, I don't care which, how is this r value right here in black changing? It isn't. It's constantly equal to
1.
1. Is theta constant?
No.
Oh shoot, I better keep that as is then. Can I just very briefly, even though I haven't differentiated yet, since over time, as the water level is changing, increasing, and decreasing, since r is going to be constant, can I just, before I differentiate, replace r with the value of, I forget,
1.
1 meter? That gives me a 5/2 theta minus 5/2 sine of theta. Okay, you guys, I'm done with my simple trigonometric and algebraic manipulations. Now I got to take a break, take a breather, realize as time goes by, both the volume and the area of the theta change expected time. And shoot, I've lost a question. I'm seriously, I really did. Can I go back? So the tank's actually draining. It's initially full of water. It's flowing at a rate of 1.5 cubic meters per hour. How fast is the water level changing when the water level is 0.5 meters from above the trough, or from 5 meters from the bottom of the trough? Shoot, how am I going to do that? Whoops, sorry, I messed up the picture. Anybody?
Well, you just do the derivative and plug it in.
I'm nervous.
Let's solve for theta.
Because if I differentiate, I get dv dt's, I get d theta dt's. Do you know what d theta dt is?
Is that not what we're
No,
trying to solve
but
for?
figure it out.
What do you mean figure it out
Derive, so take the derivative of the whole thing.
how? Okay, I will. So differentiate respect to time t, I see the dv dt is nothing more than 5/2 d theta dt minus 5/2 times the cosine of theta times d theta dt. Okay, I just did what you told me to do.
Okay, we know dv dt is 1.5, solve for d theta dt.
I can't.
Why not?
Cosine of theta is no way.
Just divide the other side
Yeah,
by
solve,
5/2 times 1 minus cosine theta.
So divide both sides of this piece.
Yeah, you could.
What would you do with the theta?
well,
That's what I'm asking.
we're gonna have a theta in our answer, but
Yeah.
we're still gonna have d theta dt. It's just gonna be in terms of thetas.
Thirds. So is that 2/3, 1 minus cosine of theta equals d theta dt? You guys
Wouldn't
are
it,
serious?
wouldn't it be 3/5
Yeah.
1 minus cosine theta?
Well, isn't this just simply
If you
Five.
if you multiply that by 2, that's going to be 3, and then you divide that side by 5 times 1 minus cosine of theta.
so 5 cancels, 2 goes upstairs?
Well,
Am I okay?
well, you could start doing by multiplying by 2 on both sides, right, to get rid of that 2 in the denominator, and then you would have 3 equals 5 times 1 minus cosine of theta, and then you divide 5 times 1
Are you
minus
saying
cosine of
reducing?
theta.
I'm sorry, if I did, double check my arithmetic. I mean,
Yeah,
1.5 is 15/10, but that's, I get it, 3/2.
yeah,
Shoot, you're right, I am bad with my arithmetic. Is that a 3/5?
3/5, yes.
I'm so sorry, I reduced to 1.5 incorrectly. How about this?
Yep.
I officially can't do arithmetic after 7 p.m. Then what though? Seriously, I'm sorry, I'm in deep trouble. Think about it, the question is, how fast is the water level changing? You know, I think in my picture, using my purple pen, I think I'm trying to find how fast H is changing spent the time. I'm not saying you've done anything wrong, but I'm trying to find dH dt. And I don't see it. Anybody?
Find an equation that relates theta to h.
How? Magic. Math magic. How?
Well,
Doesn't it have to do something with the top
1/2
ratio or
radius.
the...
yeah. 1/2 radius squared theta is the.
It's the area, yeah.
So 1/2 height,
As R increases, H decreases.
replace H with R,
I don't see it.
just throwing out ideas.
Anybody?
Well, would it not, the A and the A equals A of,
Circular sector minus area of the triangle.
the triangular sector, can we break that up somehow into the Pythagorean theorem and then solve for H?
Well, it certainly is the case of this. That if I connected this position, this point, all the way down,
Yeah,
that's R. But here's an R.
it's R over 2.
Can you build a picture that gives you something like similar triangles? I mean, no matter what theta is, I mean, is there a relationship, similar triangles, basic laws of trigonometry, basic definitions of trigonometry?
Find basic.
Find basic.
Yeah.
I mean, technically, based on your drawing, if you had the height from the top of the triangle to the base of the triangle, and then subtracted the radius from that, you would get the height.
Or you mean subtract that from the radius?
Yeah.
I get it. So you're saying this dimension right here, can I use a different color? There's a green pen. She's saying, consider this dimension right here. Somebody quantified the length of that green line segment.
The height of the triangle.
True, but in terms of R's and H's. R
Minus
minus H. I think that's height. That's this height. What's this height?
R.
R. How can you build an equation of all those quantities?
R minus...
Anybody?
R minus h equals r minus h.
That's true, always. I agree with that. By the way, it's a sloppy R. Hold on. Anybody?
Is this supposed to be common sense?
I wouldn't say common sense, but maybe some basic laws of geometry and trigonometry. Where?
Law of cosines? No.
That's the point where R hits the,
Oh, we have to find it in terms of theta.
How?
Theta over 2? Because it's split up in 2.
Oh, law of sines, right?
You know, the law of sines would really help if I knew a pair of one angle and the side opposite. I don't know that in this particular case.
Well, we don't know.
Law of sines helps in the situation where you know a combination of an angle opposite one side and the length the other side, opposite the angle. I don't think I have that in this particular picture.
Can you take the diameter and possibly do not the triangles that you have highlighted, with the unhighlighted triangles, and then subtract the highlighted from the unhighlighted? Or is that too much?
You know, I can do that, but then it gets kind of complicated in terms of what these two angles right here, I think you can generate them easily from theta, but they'd be like in terms of half of thetas. I think it'd be create a more complicated relationship.
Are we trying to find the DHD?
Well, actually, stop looking for what we're trying to find. Look at the problem we're in. You know, I've got an equation on d theta dt related to theta, but look at the question. The question is, how fast is the water level changing when the water level is some distance from the top of the trough, whatever, or bottom? So I'm trying to, in the end, I'm really trying to find dH dt. If I'm not being too sloppy, that's a t.
So it's gonna be.
Wait, we already know h, it's 0.5.
No, we know h at one particular point in time.
We know that.
Well, that h is going to be
Well,
0.5,
yeah, it doesn't matter.
and so then
I
we
think
know
it does
that
because-
r is going to be 0.5 as well.
No, you're right, r is
Yeah.
going to be constant, I agree with that. But I'm trying to find a relationship between h and t. Sorry,
Well, yeah,
so
but if we
between
know
h
that-
and theta.
If we know that h
We know-
equals 0.5, which they tell us in part A,
Nabil, you're right. That means I can probably find h in terms of what theta is or vice versa, but the problem with that is it doesn't allow me to replace d theta dt to dh dt because theta in turn was changing in time. So I need a relationship between theta and t, no matter
Oh,
what those
well-
values are, because I've got to replace d theta dt in terms of dh dt. Anybody?
So if the height is half a meter and the radius is 1 meter, and you know the lengths of the sides of the triangles at the snapshot in time, then you need to know how fast the water's draining, right?
How about this, you guys? What if I just drew a triangle? How about from here to here to here to here? Let's talk about the triangle. Let me draw it. Redrawing it, here it is. What's this length?
0.5 for r.
1 meter.
What's this angle?
Theta over 2.
Theta over 2. This is an honest question. Is that a special triangle?
it's a right triangle.
Is it?
No, it's
No.
not.
Two
Yeah, it
sides are
is.
equal.
Doesn't look like it.
How is it a right
Well,
triangle?
yeah, because he drew it like that, but it's still a right triangle. The water isn't slanted.
Nabil, do this. You imagine this trough is completely filled. Wouldn't this triangle look like this? Fingertip to fingertip to fingertip.
Yeah.
That'd be a right triangle, and that's the right angle. But as r kind of lowers itself, I don't think any of these angles in there are going to be right angles.
Pretty soon. Well,
It's half a
Wait.
right triangle then.
Wait, is the
That's
bottom
right.
part the
This length
surface
right here
of the
diagonal
water? Oh.
is that length right there diagonal.
Well, why are you using that one?
I don't know. Tell me what it's to use.